I'm going to talk about theoretical probability and relative frequency, otherwise known as experimental probability. Right, so relative frequency, experimental probability are the same thing. Let's start talking about theoretical probability. Right, let's suppose I ask what is the probability, P for probability, the next child being born is a girl. Right, so for a mother, what's the next child being born is going to be a girl. Well, you're going to say 50-50, aren't you? Half, even, 0.5, all right? That's what the theory says. But let's see what could happen in practice. Let's say out of 10 mothers, 4 of those, 4 girls are being born, okay? 4 girls are born. So what is the relative frequency? The relative frequency or experimental probability is 4 out of 10. If you want to simplify it, 2/5. That's what the theory says. It should be 50-50. But in practice, experimental, it's in this particular case, it's 4 out of 10. In a different place, it could be slightly different. Let's say out of 20 mothers, 7 of those are girls, right? So 7 girls. That the experimental probability would be 7 out of 20. So that's experimental probability, relative frequency, and that's the theory. Right, let's try a different example. Right, with a dice. Now you know there are 6 faces on a dice. What if I ask the question, what is the probability that it will land on a 6 on the dice? It will land on a 6. Well, that's only one chance, 1 out of 6, because there are 6 faces on a dice, and there's only one face with a 6 on it. That's what the theory says. That's the theoretical probability. But what happens in real life could be something different, right? Let's say you throw the dice 6 times. And for whatever reason, it lands on 6 2 times. In that case, the relative frequency or the experimental probability, because remember we're carrying out an experiment here, is 2 out of 6. Okay, so in this particular example, it's 2 out of 6, the relative frequency. But in reality, in theory, it should have been 1 out of 6. All right? You could carry it 60 times, for example, the experiment 60 times, and it lands on 6 7 times. In this case, the relative frequency, experimental probability, 7 out of 60. And another person does it 600 times. And it lands on 6, let's say, 97 times. In this case, the relative frequency is 97 out of 600. Now, if I was to ask you the question, which experiment, this one, or this one, is more accurate? This one is more accurate. Why? Because more experiment is carried out. Okay, a lot more experiment is carried out. Here is only 6 times. It's not enough. But here, loads of experiments are carried out. So this one is more accurate. And you can see this one here, 97 out of 600. If you was to simplify that, if you were able to simplify that, it would be close enough to 1 over 6, the theoretical probability. Okay, so just to quickly recap, probability of a girl being born is 0.5, probability of landing on a 6, 1 in 6 chance obviously, that's the theoretical probability. But we know in practice, in practical life, things doesn't have to follow exactly the way the theory says. Let's say, for example, out of 100 mothers, 55 girls are born. So the experimental probability, or relative frequency for this case, is 55 out of 100. Let's suppose you roll a dice 1,000 times and it lands on a 6 155 times. The relative frequency, experimental probability, is 155 out of 1,000.